Hi, this is ET370, Lecture 3, Part 3, and we're going to finish off our discussion on three-phase rectifiers. So we'll talk about the firing order and then the circuit simulation just to see everything live. Okay, so what we have here is a load, so a simple resistor with the output voltage, and here are the six diodes that comprise the three-phase rectifier. So you have 1, 2, 3, 4, 5, 6 diodes, and what's feeding it is a three-phase source. So you have three line to neutral sources, AN, BN, and CN, and then you have three line to neutral line to line voltages, VAB, VBC, and VCA. Okay. And what we're going to assume is that all three of these are balanced. So that means they have the same magnitude and they're offset by 30 degrees, or sorry, 120 degrees, or 1/3 of a cycle. Just a little review, the line-to-line voltage is actually bigger than the line-to-neutral voltage by a square root of 3. Okay, so that's just a good review of balanced three-phase and the line-to-neutral, line-to-line voltages. Also, just as a bit of, I guess, trivia, which is not really important here, but there is a 30-degree phase shift. If we have a leading sequence, A leads B leads C, then the AB voltage will lead the AN voltage by 30 degrees. If we have a negative sequence where A lags B lags C, then this would be lagging. This line to line would be lagging. But really, the takeaway is going to be that this output voltage is going to match this line to line voltage. And this line to line voltage is a √3 bigger than the line to neutral voltage. Okay. So let's plot the line to line voltages on a time waveform where the x-axis is time and the y-axis is the amplitude. So notice I have the three-phase A, B, B, C, C, A. So I have 1/3, 1/2, 1/3, 2/3 of a cycle in one period. So at 1/3 period, you can see the BC is lagging, okay? And the other thing I want you to note is that I have drawn the peaks or the maximum peaks right here on the top. So for example, in this time interval, VAB is positive and maximum, but here VCA is negative and maximum. But I flipped it, I put the negative VCA up here. Now this blue line here, this dashed blue line, is essentially going to be the output voltage, and it's pretty much DC. If we put a little capacitor here, that would just smooth that right out, okay? And what I want to highlight is how this three-phase power voltage here is going to be converted into this DC on this load resistor. So can you imagine if we're here at 0 time, we have the highest voltage being at point A relative to point B. Okay, these two voltages are lower, VCA and VBC. So this is the largest difference in voltage. So what I'm going to do is I'm going to follow with my pen over here A and B. So I'm going to have a high pressure here at A and a low pressure, the lowest pressure here at B. So if I have a high pressure here, notice between 1 and 4, 1 is going to be in forward bias and 4 is going to be in reverse bias. Okay, so that means current's going to flow out of 1. It's not going to go into 2 and 3. And it's going to go through this resistor here, okay? So now the current's going to flow through here. Now it's going to flow through here, and it's going to choose which one's the lowest voltage to go through. It's actually going to be 5 here, and so the current's going to flow into 5. So it's A through B, which is 1 and 5. That's going to be the two diodes that are going to be active in this interval of time. Okay, let's go to the next interval of time. This is a little tricky, but here we have negative VCA. Well, what does that mean? Well, positive VCA means we would have a high pressure here at C and a low pressure here at A. But negative means we actually still have the high pressure at A, but now the negative is actually at C. So look, current still flows through the first diode here, but now flows through the sixth diode. So before it was 1 through 5, then at this next time interval, it's going to go 1 through 6. Okay, good. Okay, let's follow the next point in time or the next interval of time. That's BC. All right, so now the highest pressure goes from B. So pressure is going to go here. Current's going to leave the 2. The diode 2 goes through the current and then come through 6. So it's 1, 5, 1, 6, now 2, 6. Okay, what's next? Now it's AB but negative. Okay, so what does that mean? That means that the B is going to have the high pressure, but now the A is going to have the low pressure. So it still goes out of 2 and goes into 4. Good. And then what's the next one? CA. So now the high pressure goes to C. So it goes through 3 and then goes to 4. And then we're going to go to negative BC here. So it's actually going to be high pressure at C, and it's going to go through 5. So 3 to 5. And then it goes back to AB, which means that the high pressure now goes to A, back to 1 through 5. Okay. So I summarize what I just did on this chart here. Okay, so if I look at this table, this chart, what do I have is the firing order. And let's just do it one more time to really hit it home. So in the first step, which is this interval, it's AB. So AB 1 through 5. Good. And that's what I have here. The next one is negative CA, which is actually a high pressure at A still because of the negative. So it goes 1 through 6. Okay, and that's what we should see here, 1 through 6, and we see 1 through 6, diodes 1 and 6, okay? What about the next one? BC, so that's a high pressure at B, low pressure at C, so that's 2, 6, so 2, 6, 2, 6. What's the next one? It's AB, but negative, so actually it's BA, which is like this, so that's 2 through 4, good, 2, 4, 2, 4. What's the next one? The next one is CA. So now we have C and A. So that's 3, 4. So then we got that here, 3, 4. And then finally we have negative BC, which is going to be essentially a positive at C going to B. So that's, yes, that's going to be C, that's going to be B. So that's 3 to 5. Very good. And then finally we go back to the beginning, which is 1, 5, which is back to AB. Okay. So let's confirm this through Circuit Sim and see if we get the same firing order: 1, 5, 1, 6, 2, 6, 2, 4, 3, 4, 3, 5. And notice the pattern: 1 and 1, 6 and 6, 2 and 2, 4 and 4, 3 and 3, 5 and 5. You kind of get this nice alternating pattern. Okay, let's go to check out the simulation. So we're going to go over here and screen share this guy. And notice I have exactly the same thing written out. I have the firing order written out: 1, 5, 1, 6, 2, 6, 2, 4, 3, 4, 3, 5, 1, 5. I have the line to line neutral voltages. So that's these guys in the middle. And I have the line to line voltages plotted out. And notice you can see the 173 versus 100 volts. So this is 1.73 times, or a square root of 3 times larger. And you can see the output voltage is just the ripples. And notice the value is about 170 volts. So I'm going to run this now. And what I want you to follow with your eyes are these yellow dots. Okay, you see these yellow moving dots. And right now it's 1, 5. Maybe I'll slow it down a little bit. Let me slow down the simulation. Okay, let's see if this the current in these diodes matches our firing order. Okay, so we have 1, 5, 1, 6, good. And then we have 2, 6, 2, 4, good. 3, 4, and then 3, 5, yep, and then back to 1, 5. And let me slow it down again just so that you can really see what's going on. I'll even increase the current speed. Maybe does that help? Okay, there we go. So 2, 6, good. Let's go to the next one. The next one should be 2, 4. Okay, maybe I slowed it down too much, but that's okay. A little bit faster. Let me go here. Okay. Wow, maybe slow down. Wait, there we go. 2, 4. Finally, sorry about that. 2, 4, good. And then the next should be 3, 4, good. And then it should be 3, 5, good. And then 1, 5, perfect. And then that's the repeated pattern, 1, 6 of the next one. Good. Okay, so if you're interested in playing with this 3-phase rectifier, include it in the description of the video, and you can change the parameters, you can open up these switches, change the values, but hopefully this is an intuitive explanation of how a 3-phase rectifier works with these diodes. All right, thanks for paying attention, and see you at the next one.